This is an introduction to simplifying by combining like terms. So I have the 3 steps written up above: leave, change opposite, distributive property, combine like terms. So let me start with the first one, leave, change opposite. I want to make sure that this negative gets distributed all the way through that parenthesis, so I change it to add the opposite. Same thing back here, I want the negative attached to the coefficient. I want the negative attached back here as well, so I have those attached. The other reason we do that is if it's addition, then I can use the commutative property and I can move that stuff around to get my like terms together. Next thing I want to do is distributive property. These b's right here want to be over here with these b's, but they can't because they're in jail. I consider that parenthesis like a jail, so they're stuck in there for now. So we're going to bust them out with the distributive property. Negative 4 times 3b is negative 12b. Put the plus sign back in. Negative 4 times 6 is negative 24. So we just did our distributive property and busted those guys out of jail. Next thing I'm going to do is I'm going to combine my like terms. We'll discuss like terms a little bit more later, but like terms have to have the same variable to the same power. So those 12b's match those, or negative 12b's, excuse me, match those negative 16b's. So I'm going to add those together. And I get negative 28b's. They don't match that negative 2b squared because they have to have the same variable to the same power. B squareds are not the same as b's, so those don't have anything to match up, so I'll just bring them down. This 7 right here and this 7 right here, their constants, well, their variable part matches. No variable matches no variable, so I'll add those together. And I have combined my like terms. I've simplified it. I've got my stuff out of jail, and now I've got all my b's with my b's, my b squareds with my b squareds, and my constants with my constants. Now we'll do several examples here of distributive property. Of course, we're going to do leave, change opposite if we have any subtraction. 3 times 4 is 12. 3 times negative 7m is negative 21m. Put the plus sign back in between it. And now we have 12 plus negative 21m. If I had a g times 3 is 3g. G times 6g, well, that'd be 6 times g, it'd be 6g squared. Put the plus sign back in between it. See, I have some leave, change opposite here. This sometimes confuses people what you're distributing, so remember, its identity is times 1, so put in that understood 1, and you're taking it times negative 1, so that'd be negative 4p, and negative times a negative is positive 5, and put the plus sign back in between them. And some people don't see this last one as a distributive property type problem, but if you think about that divide by 2, it's the same as times 1/2, which means both the front term and the back term are both going to be divided by 2. So 16c divided by 2 would be 8c, and 10 divided by 2 would be 5. We put the plus sign back between them. Now we'll work just a little bit on the definition of like terms. I mentioned earlier that this variable has to be the same and the power to the variable has to be the same. So anything that matches this 7f squared p is going to have an f squared and a p and nothing else as far as variables go. The coefficient doesn't matter, so you could have negative 3, you could have f squared and p, and that matches. But if I had even something that looked very similar, like 7fp squared, it seems like it has all the right pieces, but that's a p times p and an f. What I need is 2 f's and a p, right? So those do not match. Negative 6 fp almost matches, but we need another f in there. It has to be an f squared. 35 fp f squared even pg doesn't match because now we have an extra g on there. If I had negative 17 f squared, does it match? No, we need a p on it as well. So let's see, if I had 60 p squared f, does it match? No, once again, the squared's not in the right place. But if I did have 13 p F squared, some people say, well, it doesn't look exactly the same. But we do have all the right pieces. We have 1p, 2 f's, so that would be the same as 2 f's and 1p due to the commutative property. So if I look back at that, the only two that match here, we have this pf squared and we have this f squared p, but none of the others match because they don't have the exact same variable piece to the exact same power.